Okay, here we have this clock spring, and it's for a Toyota. Now the way this clock spring works is that it is the link between the steering column electronics and the onboard control units mounted on the chassis of the vehicle. So if manufacturer has connected wires directly to the steering column electronics and to the control modules on the chassis of the vehicle, as you turn the steering, those wires are all going to entangle up on the steering column tube, and they might end up breaking, causing a serious short and even injury. So inside here you have a ribbon cable that is wound up like this, several turns, 5 turns. So that ribbon cable is what the engineers designed, came up with, so that they can have a link between the controls on the steering column, communicating to the modules on the chassis of the vehicle. Alright, so this is the connector here. It has a single pin. You can see, if I draw it closer, there's a single pin right there. Now that pin is for the horn, grounding the horn for it to be activated. And these wires here, they help deploy the airbag on the steering column in case of a crash or something related to that. So we're going to disassemble this one safely, because this one is still okay, it's still functioning. I'm going to show you how you can test it with a multimeter to be able to determine if it is faulty or still working. So normally what happens when this one fails is that there's a break somewhere in between that ribbon cable, because of those tiny sensitive buses that are on the ribbon cable connecting the steering wheel to the airbag control module. So most of the times when you see the airbag lights flashing or the check engine light, and when you scan the vehicle, it tells you that it has a problem with the driver's squib or driver's airbag module, the fault is usually related to this ribbon cable inside this unit here, this accessory, having a break somewhere on that line. Okay, we have a multimeter right here. I want us to go ahead and test the continuity, see if we have a proper connection of continuity from end to end, from these connectors right here up to this point where this is where the electrical signals enter this unit, and then this is the point of exit. The signals travel to the modules I told you before that are mounted on the chassis of the vehicles. So we want to go ahead and check the integrity of this unit right here. So I'm going to start with the airbag, checking the airbag connections. Hook my pin right here, and then I'm going to touch this other end, and I want you to observe the multimeter. So if I touch it like that, you have continuity. That one is good. The yellow wire is good. If I check on the blue one, we also have good continuity. Then I'm going to test the horn pin here, this single pin right here that is separated. Now the reason why these pins are separated is because an airbag is a very sensitive component of the vehicle, and to avoid the risk of any short circuit and deployment, they have to make sure the connections are separated. So this one here is the wire, the pin for the horn, and if I come here to this single pin right here for the horn, right, I have good continuity. So that one is confirmed. The accessory is good. Okay, I'm going to use this self-made prying tool. Fit it right here like that, and then I'm going to fix this one here. This plastic, it's a tie wrap like that. Then I'm going over to the other side right here. I'm going to fix my little prying tool. Fit my plastic DIY tool. Then come to this point right here. my plastic tool like that. Okay, and then the last one here, you have to check the other side of the connector. So those ones are put in place. I think I'll have to come here on this side where the connectors are. I carefully remove this tab, then fit my plastic tie wrap DIY tool to this other side, lift it like that. And then from that point we come to the center of it. I'm going to pry on these tabs. Okay. So now I have to remove it. And then it is out. See? So this is the ribbon cable I was talking about. See the one that we are measuring with the multimeter? Comes all the way up to here. This is the end, the limit that has been designed by the manufacturers. Now you can see we have some powdery stuff around here. Looks like dust. This is not dust. This is for protecting the ribbon cable from heat. When someone is aggressive on the wheel, or it has been turned around so many times, you know, there's that little thing of heat tending to generate where there's some friction. So to minimize the risk of breaking it, they use this powder. It's kind of like a lubricant to make sure the ribbon cable is safe as you're operating it. It usually has 3 buses, and these 3 buses, you can see the 3 buses for transferring electrical signal from one point to the other. So those ones are essentially wires, carefully and cleverly designed to be very thin so that they can fit in this whole chamber. You can see we have 2 big ones and a small one. The small one on this end right here is for the horn, alright, and then the 2 ones here are for the airbags. So when we are checking for continuity from one end to the other, you are checking the integrity of this ribbon cable, and it turned out okay, right? You can see those pins right there, they connect to the ribbon cable. So that's what this component is all about. So I'm going to put it back together. So what I'm going to do is I've fitted this connector right here, the position is supposed to fit in. I'm going to fit this outer shell, make sure the ball is right at the end, and then I'm going to fix this one gently into place, and then to pick up this other end. Fix it like that in the middle. Then I'm going to pick up this other part. Alright, this is supposed to be the bottom part. It's going to come and fit it on the bottom side like that. Right, now the unit is complete as usual. So let's go ahead and check continuity first to be sure that we've done it perfectly. So I'm checking the yellow wire of the airbag, that one, the first wire. So if I touch here, we have continuity. Next is the blue wire. If I check on the second wire, we have good continuity. And then the final one is the horn. That one is also good. So we are done for that part. Alright, so the specifications are, it's 5 tons, either side should be 2.5, about 2.5. So if I turn to the left, so that's 1, 2.5. Alright, this is where the half mark is. So half, 1, 2. Now turning to the right side, that's 1, 2.5, right? So half, 1, 2. Now that is the center. That is where you are supposed to mount it on the wheel, exactly at that point. If you are turning to the right side, it will only make 1.5 turn, and there will be a limit right there. The stops will stop it right at the end, and the steering angle sensor will have already recorded the degrees, the amount of degrees it has turned, communicate to the onboard control unit. So right now, if my steering turns to the right side 1.5 turn, and then back to the left side 1.5 turn, all the way from end to end, it means that the steering is only rotating 3 turns. Okay, so that's 1080 degrees. So if you divide 1080 degrees by 2, you get 540 degrees. That means that if I decide to turn to the left all the way to the end, the steering will only rotate for 540 degrees. Okay, the whole travel from left to right, end to end, will be 1080 degrees. So that means that the 2.5 tons the manufacturers have given out or have specified, they have already given out an enough allowance to protect that ribbon cable, because 2 tons, that's 360 times 2, that's 720. And if you add the 180, it becomes 900 degrees. Okay, so instead of traveling all the way to 900 degrees, it only travels to 540 degrees. Okay, slightly above half of 900 degrees. Thank you for watching. Like the video, subscribe and share it.